Hi, welcome to this video looking at Year 11 changing the subject for the higher tier GCSE 9 to 1 maths from the White Rose Maths website. So White Rose are a really fantastic resource for Key Stage 1, Key Stage 2, Key Stage 3 and even Key Stage 4 maths, okay? So this section is aimed at predominantly the higher tier, okay? And then the next section is looking at the same topic but for the foundation tier. Okay, so if you're doing foundation, then please skip ahead. Okay. As ever, feel free to obviously pause the video, try the questions first, try all the questions first, and then press play when you're ready. We're going to start with question number 1. Solve 19 equals 4 plus 5c. Well, if I take away 4 on both sides to balance the equation and to isolate the letter by itself, 19 take away 4 is 15. 15 is equal to 5c. Okay, 5c means 5 times c, so dividing both sides by 5, okay, means that I isolate and get c by itself, okay? So we are trying to solve an equation, so we're trying to isolate and get just the letter by itself. 15 divided by 5 is 3, and 5c divided by 5 is just 1c, or just c. So c is equal to 3, or 3 equals c. Again, it means the same thing, okay, but different ways of writing it. This is question number 2. Solve 2x minus 1 is greater than 5. Show your solution on a number line. So it's solving a inequality treated the exact same way. So add 1 to both sides, okay, I get 2x is greater than 6, dividing both sides by 2, because 2x means 2 times x, so dividing both sides by 2, we get x is greater than 3. Okay, so x is strictly greater than 3. Now, representing this on a number line, okay, means that I have a hollow circle because it's not got the equal sign and it's greater than 3, so it's going in this direction. Okay, so it can take the numbers 4, 5, 6, 7, 8, 9, 10, etc, etc, and it goes on forever. Okay, but x has to explicitly be greater than 3. X cannot equal 3 because it won't satisfy this equation. X has to be greater than 3. So part B of a question might say, what is the smallest possible integer that satisfies this? And the answer would be 4, okay, because 4 is the smallest one that would satisfy this, okay, because integer means whole number. So watch out here, so it might throw that in there as part B or part C of a question. Okay, question number 3. Make f the subject of h equals 3f minus k. Well, if I subtract k on both sides, okay, so we are trying to isolate and get the letter by itself. H take away k is equal to 3f, okay. 3f means 3 times f, so dividing both sides by 3 will isolate and get me, oops, why did I divide by f there? I mean divide by 3, sorry. Okay, so your final answer, divide by 3, okay, we get h minus k all over 3, okay, as a fraction, okay, or they will also accept h over 3 minus k over 3, okay, either way is fine, but I'd probably leave it just as this fraction, okay, so everything is being divided by 3, guys. Okay, this is question number 4, guys. Ron has rearranged Pythagoras' theorem, a squared plus b squared equals c squared, to make b the subject. Here is his working. A squared equals b squared plus c squared. B squared equals c squared minus a squared. That seems fine to me, yep. So taking away a squared on both sides. Okay, here is where the problem lies. So it should be b is equal to plus or minus, okay, the square root of c squared minus a squared. Now, I can't separate that, okay, so I can't separate that into plus and minus root of c squared plus or minus the square root of minus a squared, okay. So here, it should have been this step actually rather than that step, okay, because it's a square root of the whole thing, okay. I can't separate c squared and minus a squared, okay. I can't put that into two different square roots, okay. There is no third rule that allows that, okay. So b should be equal to plus or minus the square root of c squared minus a squared, okay. They've put c minus a here because they have square rooted this, but I can't separate that, okay. If it was c squared a squared, yes, okay, but it's c squared minus a squared, so I can't just separate that into two components, because if I square c minus a all squared, I don't actually get c squared minus a squared, I get c squared minus 2ca or 2ac plus a squared, okay, if I try and work backwards. So I end up getting something that looks like this, okay, just like prove my point further, and it's a minus a squared there, so but we've got a plus a squared here, so that tells me straight away that I can't even do that, okay, because I'm missing this term here, and it should be a plus a squared, okay. Anyway, so that's Ron's mistake, okay. So squaring that, I cannot separate the variables into square roots, okay. Question number 5. D equals the square root of 3h over 2. Make h the subject. Well, if I square both sides, I get d squared is equal to 3h over 2. Timesing up both sides by 2, I'm going to get 2d squared is equal to 3h. Dividing it by 3 will get me the h by itself. Okay, so 2d squared divided by 3 gives me the letter that I want, which is h, okay. And again, if I want to write it as 2/3 d squared, that's also fine, okay, but I'm going to just leave it as it is 2d squared divided by 3, okay, for that one. Okay, this is question number 6, guys. Make x the subject of the formula 3x plus a equals b brackets x minus 4. Okay, so if I expand the right hand side bracket, okay, I'm going to get bx minus 4b, so b times x is bx, and then b times negative 4 is negative 4b, okay. I'm now going to bring all my x terms together, okay, and all my non-x terms together, okay. So I'm going to have 3x minus bx, okay, is equal to minus 4b minus a, or minus a minus 4b, okay, either way is fine. Okay, minus 4b minus a. I'm now going to factorize the x out, okay, brackets 3 minus b is equal to minus a minus 4b, or minus 4b minus a, either way is fine for the right hand side, okay. I'm now going to divide by, or divide through, by 3 minus b to get x by itself, okay. So x is equal to minus a minus 4b, okay, all over 3 minus b, okay. Now this is the same, okay, this is the same as writing it as a plus 4b divided by b minus 3. And what I've done here is just multiplied through the fraction everything by negative 1. Okay, so I get minus 3 plus b, or b minus 3. Okay, that's also fine. That isn't going to change the left-hand side because I don't have to worry about that. Okay, so that's just a different way of writing the right hand side. Okay, so without changing anything, it doesn't change the letter here because I'm not timesing everything by minus 1 ever. Okay, because if I times it by minus 1 here, then it will change the sign automatically for the right hand side. Okay, because you might say, well, it'll be a plus 4b over 3 minus b, okay, and keep the top part positive but keep the bottom part negative when he times it by minus 1. But that's either the same convention, okay. That's just timesing the fraction top and bottom by negative 1, okay, and writing it in a slightly different convention, okay, but it means the same thing. Okay, this is question number 7. Make d the subject of this formula. R is equal to d plus 4 over d minus 3. Well, multiply both sides by d minus 3. So we got r lots of d minus 3 is equal to d plus 4. Okay. Expanding the bracket on the left hand side, I get dr minus 3r is equal to d plus 4. Bring the d to the left hand side and bring the 3r to the right hand side. So bring all my d terms together and all my non-d terms to the right hand side. Okay, so then I get dr minus d is equal to 4 plus 3r. So 4 plus 3r. If I factorize the left-hand side out, guys, okay, taking out a factor of d, I get d brackets r minus 1. That has to equal 4 plus 3r. And then dividing through everything by r minus 1, so dividing both sides by r minus 1 isolates and gets d by itself. Okay, so then I get 4 plus 3r all divided by r minus 1. Okay, for that one there. Okay, and question 6 and question 7, guys, are what are called rearranging formulas where the subject appears twice. Okay, so the only way to separate it is by getting all the letters onto one side, factorizing it, and then dividing through by the bracket. Okay, so this is what it's called. Okay, rearranging formulas that appear twice, or where the subject appears twice, I should say. Okay. So slightly more tricky example. So these are like possibly grade 6, even grade 7 maths that we're looking at here. Okay, question number 8. Show that w is equal to 13 minus 9 over w is a rearrangement of w squared minus 13w plus 9 equals 0. Okay, so times through everything by w. So now I get w squared is equal to 13w minus 9. Okay, rearranging it and getting the quadratic to equal to 0. So bringing the 13w on this side so the sign switches, bringing the minus 9 on this side so the sign switches. So I'm essentially adding 9 to both sides and taking away 13w on both sides. Okay, simultaneously. Okay, subtract 13w. Okay, I get w squared minus 13w plus 9 is equal to 0. Okay, and that is my quadratic equation. Okay, equal to 0, and I can solve it if I want to. Okay, by completing the square or the quadratic formula, because it doesn't give whole number solutions. Next question. Okay, let's just delete this part here so we got a bit more space. Okay. Okay. Right, show that W0 equals 12. Starting with W0 equals 12, use the iteration formula Wn plus 1 equals 13 minus 9 over Wn to find an estimate to the solution W squared minus 13W plus 9 equals 0. Okay, so W1, okay, when n is equal to 0, okay, I'm going to sub it into here. I get W1 is equal to 13 minus that, okay. Now I'm doing this on my calculator, okay, so 13, okay, minus, okay, so it's 13 minus 3/4, okay, so it's 12.25, okay, for W1, okay, so that's when n is equal to 0, okay, n is equal to 0, I get W1 equals 13 minus 9 over W0, W0 we are told is 12, okay, so it's minus 9 over 12, W2, okay, I'm going to have 13, so that's when n is equal to 1, I have 13 minus 9 over 12.25. Now what's going to start happening is it's going to give me a number, so it will get closer and closer to like a certain number, okay? And our job is to recognize what that number is, okay? So then the next one gave me 12. Okay, so this one's going to go for a bit longer. 12.265306. Okay, 1, 2, 2. Okay, and it equals 2. I'm going to get W3. Okay. So, changing this now. Okay, so I'm going to have 13 minus 9 over 12.2653, I think it's 172, I think it was, or 112. Okay. So when I do that, okay, let's see what happens. Okay, 122, sorry, it should be a 2, not a 7. 12245. Okay. So 12.26530122. Okay. 45. Now I get the answer this time of 12.2662. Okay, so I can start to see, okay, that it's obviously, yeah, it's going to be in between this, okay, so if I just carry on actually and do one more. Okay, so if I do 13 minus 9 divided by 12.26222. Okay, so it's getting closer and closer. Okay. So W is equal to 12. 12.26, because if I keep going further and further here, it's going to get closer and closer to 12.26 to 2 decimal places, okay, because it's going to bounce between 12.26 and 12.7, okay, if you truncate the 3rd decimal place, okay. So 12.26 is what I'm saying, okay? Because it starts repeating again each year. So 12.2660382867 is very, very, very similar to the previous one, which is 12.265302122. Okay, it's obviously getting closer and closer to 12.26, okay? Right guys, we are now looking at Year 11 Foundation tier for changing the subject. Okay, so this one's aimed at slightly lower level. So I would say grade 4, 5 actually, maybe even grade 6 actually for some parts of it. Okay. Question number 1. Solve 2a is equal to 80 while dividing both sides by 2 to isolate the letter by itself. We get a is equal to 40. Okay, this is question number 2, okay, or part 2 here. B divided by 4 equals 12. Well, timesing by 4 on both sides of my equation to balance it, B is equal to 12 times 4, which is 48. Okay. 3rd question, 19 equals 4 plus 5c. Well, if I subtract 4 on both sides to balance it, I get 15 is equal to 5c. Dividing both sides by 5, I'm going to get that c is equal to 3, or 3 equals c. C is equal to 3. Okay, it's just writing it backwards. Okay, dividing it by 5 there. Okay, because if you have a number next to a letter, then it means times. So the opposite would be divide. Okay, 2a means 2 times a. So the opposite of times by 2 is divided by 2. Okay, and the opposite here of times by 5 is divided by 5. Okay. This is question number 2. Solve the inequality. Well, if I add 1 to both sides and then divide it by 2, I get 2x is greater than 6. Dividing both sides by 2, I get x is greater than 3. Okay, so it's a hollow circle and it's greater than 3. Okay. This is question number 3, guys. The area A of a triangle is given by the formula A is equal to half base times height, half BH, where B is the length of the base and H is the perpendicular height. The area of the triangle is 30 centimeters squared. The base of the triangle is 8. Find the perpendicular height. We're going to have 30 is equal to a half times 8 times H. Well, a half times 8 is 4. So on the right hand side, I'm going to get 30 is equal to 4h. Dividing both sides by 4 will get me what h is. Okay, so dividing by 4, okay, respectively, okay, 30 over 4 is the same as saying 15 over 2 or 7.5, okay, centimeters. Okay, I'm going to leave my answer as a decimal here, okay, but a mixed number is also welcome and it's also fine as well. Okay. Okay. This is question number 4. Make f the subject of each formula. R is equal to 3f. Well, divide it by 3 because 3f means 3 times f. So divide it by 3. I get f is equal to r over 3. Okay. G equals f divided by 5, so timesing both sides by 5, okay, to get rid of that fraction on the right hand side, okay, f is equal to 5g, okay, but I think they will allow, yeah, if you wrote as g times 5 or 5 times g, then I think examiners will be ever, but try to always remember that if you're timesing a letter by a number, then write it as a number and then the letter next to it without the times sign. Okay, but I can't see like if you wrote it as 5 times g, then I can't see that being an issue as well, okay, because I think they all mean the same thing here, okay. You've got to be very, very, very careful and very, very, very mindful, okay. That's G there. Okay, H equals 3F plus K minus K on both sides and then divide by 3. Okay, so the answer is H minus K or H subtract K all divided by 3. And again, examiners will allow if you put H over 3 minus K over 3, okay, or 1/3 H minus 1/3 K, okay, they all mean the same thing. Question number 5. The formula density equals mass over volume links density, mass and volume. Which is the correct rearrangement of the formula for M as the subject? So M is D times V, okay, times in both sides by V to get M on its own. Which is the correct rearrangement for V? Okay, so times up by V, divide by D. So it's M divided by D gives me the volume, okay. These all mean the same thing, but it's just written in a different way. This one's to work out density, this one's to work out mass of an object, and this one's to work out a volume of an object, okay, given its mass and its density, okay. Question number 6. Ron has rearranged Pythagoras' theorem to make, okay, a squared plus b squared equals c squared to make b the subject. Here is his working. A squared plus b squared equals c squared. B squared equals c squared minus a squared. That's fine. Yep, so first step's fine. Here is the problem, okay. So b has to equal plus or minus, okay, the square root of c squared minus a squared, okay. When I take the square root actually here of c squared minus a squared, I can't like separate that actually, okay. And if I try and work backwards and square b, I get c minus a all squared, and if I square that, yeah, I certainly don't get c squared minus a squared. In fact, I get c squared minus 2ac plus a squared actually, which is not the same as c squared minus a squared, okay. So that's like another way of like checking your answer by working backwards, okay, if you expand that. So if I went from here to here and I said that b squared equals c minus a squared, that's not the same as c squared minus a squared, okay. So the mistake here is that he's taken the square root of each part, but I can't do that, okay? I can't do that specifically. I can't separate c squared and minus a squared into two separate surds, okay? If it was c squared times a squared, then I can still write it as ca or ac, but I can't actually, okay, because that's actually the same as saying plus or minus the square root of c plus a times c minus a, because it's the difference of two squares here. But if I square c minus a, I certainly don't get c squared minus a squared actually. I get c squared minus 2ac plus a squared, okay. So rearrange it to make b the subject. So b is equal to plus or minus, okay, the square root of c squared minus a squared. Now, if we're looking at in terms of Pythagoras, obviously we can just ignore the minus root sign. But if you rearrange something that has a squared in, you always have to put the plus and minus. Now, it depends obviously on the context. If you're looking at length, volume, area, these all have to be like positive values. So you would obviously disregard the negative. But for the purpose of rearranging a formula, you would still stick the minus sign at the front, because if I square a negative I get a positive, and if I square a positive I get a positive, okay. So it will still give me the same answer if I square it, okay. But I can rewrite it as well if you're interested as plus or minus, okay, c plus a times c minus a, because that's the difference of two squares inside the bracket, if you're interested. Those of you that want to write it in like a simpler way, c minus a. Okay, so plus and minus the square root of c plus a times c minus a, because it's the difference of two squares there. Okay, c plus a times, there should be a bracket there, not a k. Okay. This is question number 7. D is equal to square root of 3h over 2. Well, if I square both sides, because that's the opposite of square rooting, multiply by 2 and then divide by 3, okay, I get that h is equal to 2d squared over 3, okay? So I've kind of actually jumped the gun here. Okay, so times up by 2 on both sides, and then divide through by 3, okay, after you've times by 2. Okay, so I get 2d squared is equal to 3h, and then dividing both sides by 3 to get h on its own to isolate h. Okay, remember that I'm always balancing it on both sides. Okay, 2d squared divided by 3, okay, or 2/3 d squared is also acceptable, okay? So 2/3 d squared is also acceptable, okay? And I can't see why examiners would say that this is also an issue, but remember that GCSE we are avoiding writing division here. So division, we should be writing it as a fraction, remember, okay? But I can't see that being an issue either, 2d squared all divided by 3, okay? So it's all divided by 3. Okay, in the bracket there. Okay, right guys, that takes us to the end of today's video. So thank you so much for watching. If you did find it useful, if you found it informative, please press that subscribe button, drop the video a like, and also click that bell icon so you don't miss out on further videos and further uploads. Okay, but that's it for me today, guys. Thanks for watching, and I'll see you for the next one. Bye for now.